Alright, so guys, today what we're going to do is we're going to look at real-world application with word problems, writing linear equations and graphing them using word problems. Alright, example 1, it says, in the aftermath of a hurricane, a tent city houses 1,045 refugees. They are to be moved by bus to better accommodations. Each bus can carry 55 passengers, and assuming that every bus departs with a full load, write a linear function that relates the number of bus loads already departed to the number still remaining. Graph the function that models the situation. So the question, we have to look at, write a linear function that relates the number of bus loads. All right, so number of bus loads already departed. So that's going to be one of your variables. The other one is going to be the number still remaining at Tent City, number of people. Okay, number of bus loads already departed to the number of people still remaining. So those are our two variables. So we'll call B buses departed. We will call P the number of people left in the tent city. Now we have to figure out which is our dependent variable, because that's going to be the one that's by itself on the left side of the equal sign. Do the number of buses that have departed depend on the number of people remaining? Or does the number of people remaining depend on how many buses have departed? That second way sounds much better. It depends. Okay, the number of people left depends on how many buses have departed. So we know that P is going to be by itself on the left hand of the equal sign because it's our dependent variable. So number of people equals. All right, so what we need to do, we need to talk about how many passengers or refugees we started with. Okay, we've started with 1,045 refugees. Okay. Now, the number of people left, let's think about this. When we have bus loads leaving at 55 people a bus, that means we need to subtract from 1,045. This is our starting number of people. We need to subtract from this how many have already left. Well, if passengers, or the number of buses that have left, we need to multiply that by 55 because that's how we calculate the number of passengers that have left, because we take 55 times the number of buses. And this right here is our inequality. Our linear function. The number of people equals 1,045 minus 55b, because every bus that leaves, we take 55 more people away. So that would be our equation. For graphing that function, we are going to actually do that in class tomorrow. So right now we're just going to be setting these up. We'll do this graph tomorrow. All right, let's look at example 2. All right, students in the 9th grade class drew the following graph to represent how much money that would be in the class fund after selling sets of photos for their year's activities. So it looks like what we've got here is we've got money on the left, so that's our dependent variable, how much money they're bringing in for the fundraiser. And then below is the number of sets of photos that are sold. We need to talk about these lines, these points kind of create a line. And we need to talk about what the slope and the y-intercept of the graph mean for the given situation. Now, the y-intercept, if you remember, is where the line crosses your vertical axis or your y-axis. Your y-axis is this one, all right? So it asks us, letter A says, what do the slope and y-intercept mean? Well, let's talk about the y-intercept. The y-intercept is right here. It's probably at about $22 or so. So what does that value tell us? Okay, so the money situation over here, this is how much they have in their account. Okay, and as they sell the number of photo sets, that amount of money goes up each time. Okay, so what this right here is going to be, it's going to be the starting amount because they haven't sold any pictures at this point because we're at 0 here. So we've sold no pictures, so this is our starting amount. Okay, so we have our starting amount. That's what the y-intercept means. And then for the slope, it's a rise over run. So when we rise, we go up a certain amount of money and we run one picture packet. So for what this slope means is for every picture packet we sell, or for the number of sets we sell, we get so much more money into our account. So this right here, when we find the slope, if we look here, it looks to be goes up to about 50 probably. Here's 50, up to 50 and over 1. So it looks like maybe they cost about $10. So this is, I mean, this just represents, the slope represents how much money you get per picture packet or per photo packet that you sell. So that's what your slope means, because it's going up by the amount of money you make at each photo, each set of photos that you sell. So that's what the y-intercept and the slope mean. Now let's look at question B. If the graph had the same slope but a y-intercept of 40, what could we conclude? So let's put some values to the slope and y-intercept. If the y-intercept is 40, what that will mean is that we have $40 to start. Okay, that would be what our y-intercept meant. And then if the graph had a slope of 12.5, what could we conclude? Well, what that would mean is that each picture or photo packet, they earn $12.50 on for every photo packet. So that is what our slope and y-intercept will mean for that situation. Right, so that's how we can apply, those are some couple of different examples of how we can apply linear equations. Thank you for listening.